In this video, we'll talk about batch system wall times on the NIH Biowulf cluster. Wall time is the time in which you expect your job to complete. All jobs have a wall time, either due to the default wall time of the partition to which the job was submitted, or an explicit wall time set when the job was submitted. Jobs exceeding their wall times are killed by the batch system. To discover the default and max wall times for each partition, use the batch lim command that was introduced in the partitions and scheduling video. So for instance, in this output, you can see that the multi-node partition has a default wall time of 8 hours and a maximum wall time of 10 days. You can also set a specific wall time by using the --time equals option to either sbatch or swarm with the syntax shown, where D stands for days, H for hours, M for minutes, and S for seconds. And here are 3 examples of times being set for 12 hours, 36 hours, and 2 days, 12 hours. If you use the bundle feature of Swarm, Swarm will modify the time set for each of the subjobs. Let's say you have a Swarm job that does not use bundling, and you expect each job will run for 2 hours. If you now submit the same Swarm with a bundle factor of 20, Swarm will submit the subjobs with the wall time set multiplied by the bundle factor. So in this case, each subjob will be submitted with a time of 40 hours. If the recalculated time is greater than the partition time limit, Swarm will return an error and you'll need to reduce the bundle factor. You can increase wall time settings if your initial time estimate was too short by using the new wall command and specifying the job ID and new time specification as shown. A nice feature of Slurm is the ability for it to warn you by email when a job reaches a certain percentage of its time limit. So here are options for being notified at 50% of the job's time limit, 80%, 90%, and when the job reaches its time limit. So how do you estimate what kind of wall time to set? First step is to run some test jobs or a small test swarm with time set to the max wall time for the partition you're submitting to. Once the jobs have completed, check their run times with either the jobhis command, sackit, or the user dashboard at hpc.nih.gov. And these commands are covered in the job monitoring video. You can then submit subsequent jobs with the time from step 2 plus 10 to 20% as a buffer. It should be emphasized that choosing accurate wall times is very important for the efficient running of the cluster. At any one time, there may be tens of thousands of jobs in the system. Accurate wall times helps the scheduler to effectively schedule jobs into time slots without constantly having to calculate due to jobs ending at unexpected times. Setting longer wall times than needed can also result in longer wait times in the job queue. Finally, long wall times may intrude upon maintenance window reservations, which can result in significant delays in jobs being started. These points are covered further in the partitions and scheduling video. And that concludes this video.